Hello everyone, and thank you for joining my talk on the history and future of Openstack, a Python-powered open source cloud. I'm very pleased to join you for this conference, PyCon Iran. It's the first time I've been given the opportunity to talk here, and so I'm very glad for the invitation. And I hope that you'll learn a few things out of this presentation. First, a few words about me. My name is Thierry Carrez. I'm the General Manager at the Open Infrastructure Foundation, the foundation that is behind the Openstack project. And I would like to spend this time to explain what our mission is, what happened during the first decade of Openstack, and what we want to do for the next one, but also lessons for Python and Python developers that can be learned from the Openstack experience. So I hope you'll enjoy it. So first, what is our mission as a community at the Open Infrastructure Foundation? When people ask me what is our mission, I generally answer openly developing open infrastructure. And there are multiple components in that sentence, openly developing open infrastructure. First, what do we mean by openly developing? So we built Openstack from day zero following a basic set of principles, which we called the 4 opens. It is a crisp set of principles that reflected how we openly collaborate between equals all over the world on a level playing field. So the first open is open source. Everything we do is open source, and it's licensed under an open source initiative approved license, so that it's really open source. It's not open core or source available or all of those things that are not truly open source. There is no features being reserved for proprietary products. There is nothing that prevents you from having full access to all of the software without restrictions on usage. There is open development. Everything happening in development should be transparent and accessible to everyone. So you can easily join all of those forums where the discussions on development happen. There is no secret being held outside of the public view. Beyond that, we do open design. The design of the software should also not be done behind closed doors. It should happen everyone in the open. It should happen in person or at our virtual events so that everyone can join. And it should involve all of our community, especially users, not just developers. And finally, we have open community. The fact that our community is open to everyone, regardless of who their employer is or which country they're from. There is no reserved seats for specific companies. Anyone can rise to a leadership position. The only valid currency in our community is individual contribution. Through your contributions, you get recognition from your peers and you get elected to those leadership positions. That's the only thing that matters. So those are the 4 principles that drive how we collaborate in Openstack, but also more generally at the Open Infrastructure Foundation. But in addition to that, we believe in a few other things. Some say that the 5th open is open minds. The fact that we embrace diversity in all of its forms, like countries, geography, everything. The wealth of opinions and feedback makes us stronger. We also believe in open operations. The fact that we believe that open collaboration should not be limited to the production of code, but also to how we operate that code in production, trying to be more transparent, to share best practices between operators of the software. We also believe that free software needs free tools, that you should use free and open source software to build free and open source software, and that you should not be relying on proprietary services like GitHub or other giant proprietary forges, because that means your software is not really free. If tomorrow GitHub decides that you can't access it, then you're stuck and you can't really continue developing the software. So for your software to be truly free, you need to use free software tools and free operations in order to produce it as well. And finally, we believe in the central role of quality assurance and continuous integration. Early on in OpenStack, we had a saying that said, like, if some software is not tested, it should be considered broken. Automated testing and CI are not added afterwards as an afterthought. They are the cornerstone on which our products are built. So those are the principles that drive how we collaborate. This is what we mean by openly developing. So now what do we mean by open infrastructure? Well, first, we need to explain what we mean by infrastructure. What is considered infrastructure? When you talk about application delivery, traditionally you would represent it like this, with applications on one side and users accessing those applications on the other side. But the way you deliver those applications has been evolving. 20 years ago, you would procure some physical hardware, and as an application deployer, you would install an operating system and your application on top of it. But then we started adding more layers. We added hardware virtualization, abstracting the server you're deploying on from the physical hardware that runs it. Then we added cloud APIs to allow to programmatically access those virtualized resources. So you have programmable infrastructure on one side and cloud native applications being deployed on top of that. More recently, we added a new layer, application deployment APIs. That is what Kubernetes provides. Higher level primitives to deploy complex applications on top of this infrastructure. So you're getting the idea here. There is this growing separate role of providing infrastructure for others to develop and deploy on. And that is what we mean by infrastructure. That is what where our focus is. Providing infrastructure for others to build and deploy applications on. And those infrastructure providers are the population that we actually care for. We serve those infrastructure providers. We help the people who build and operate infrastructure. It can be public infrastructure for anyone around the world with a credit card, or it can be private infrastructure for the needs of a given organization. But the job is basically the same, and we help in both cases. So that's what we mean by infrastructure. But what do we mean by open infrastructure? Open infrastructure is infrastructure that is built on open source solutions. And when we say infrastructure being built using open source solutions, you have to realize that back in 2010, all infrastructure was provided using proprietary software. You would have VMware would be the proprietary software company that owned all of private infrastructure for all the companies around the world. And Amazon Web Services was the only real public cloud available for doing public cloud type deployments. But there are a lot of benefits in using open source for providing infrastructure. You have the traditional open source benefits, like the fact that it's not costly. Access to the source code is basically free, as in free beer. And as software eats the world and becomes ubiquitous, the old software pay-per-seat models are getting less and less desirable. So cost is a very important factor. Open source is also available. There is no barrier to trying out the software with all of its functionality. You can simply evaluate the software for future use, experiment with it, or just have fun with it. There is no friction going from that experimentation to production. Open source software is also sustainable. When an organization makes the choice of deploying software, it does not really want it to be left out without maintenance because the vendor changes its mind or goes bankrupt. The source code being available for everyone to modify means that you're not relying on a single vendor for long-term maintenance. Open source software creates an open job market too. It makes it easier to identify and attract talent. Enterprises can easily identify potential recruits based on the open record of their contributions to the technology that they're interested in. Conversely, candidates can easily identify with the open source technologies an organization is using. So they can join a company with certainty that they will be able to capitalize on the software experience that they will grow there. Open source software is also transparent. Access to the source code means being able to look under the hood and understand by yourself how the software works or why it behaves the way it does. This transparency also allows you to efficiently audit the software for security vulnerabilities. Open source software is self-service. You have the ability to take and modify the source code, which means you have the possibility to find and fix issues by yourself without even depending on a vendor. And finally, with open source, you have the possibility to engage in the community developing the software and to influence its direction by contributing directly to it. That gives you extra flexibility to adapt to future needs and makes the software grow the features you will need tomorrow. So those are all the benefits that explain why open source in general is so popular today. But they also apply for infrastructure being developed using open source. But beyond those traditional benefits, open source, open infrastructure really matters. Why? Because open infrastructure enables everyone to have access to infrastructure providing technologies anywhere around the world without having to ask for permission. We think that all of the world infrastructure needs should not be provided by a handful of US-based internet giants. Concentration of technology in the hands of a few companies located in a few countries is not good. This creates monopolies, and we all know that monopolies are not good for users. Because the monopolies can dictate their pricing and their conditions. But also, having everyone use the exact same software creates a monoculture. So whenever Google goes down or AWS breaks down, a lot of websites and sites all over the internet get broken because they all rely on the very same technology. And finally, data sovereignty is important. Not having to answer to laws of the country where the data is stored, but your own country is actually good. So using open infrastructure, you enable everyone to build their own local interoperable solutions. That's really our mission at the Open Infrastructure Foundation, openly developing open infrastructure. And we're now 11 years into it. So what happened in that first decade of open infrastructure? Well, obviously Openstack was created back in 2010, originally as a collaboration between Rackspace and NASA. It was really as a reaction to infrastructure being so dominated by proprietary software. I mentioned VMware and AWS before. There was really no other solutions back then, and that's when Openstack was formed. Openstack is a cloud software framework. So it's basically a bunch of APIs that let you programmatically access infrastructure. So you can request a block storage device, or you can request a virtual machine, or you can request a container orchestration engine. There are multiple type of resources that you can request, and you can use APIs to do that. It started just with object storage and virtual machines, And its original goal was to fit the need of public and private clouds alike. We had the needs of private clouds being represented by the NASA folks, and we had the needs of the public clouds, which was represented by the needs of Rackspace. And they decided to collaborate together and do it in open source under the Apache 2 license in order to publish the code and make it available for everyone. And that's the moment where we decided to use Python. So why Python? We are at PyCon Iran here. And so it's important that I explain why we ended up choosing Python and what we brought to Python. So Python, the main reason we opted for Python was distribution integration. Python is exceptionally well supported in the distros, and we saw Linux distributions as the main channel for our software. So using a language that is strongly integrated with Linux distributions was really a plus. Python is also easy to read, easy to learn, easy to patch when you find a bug by yourself. There is a good familiarity about Python in the operators world, so that also catered to our designated audience. It's a great integration language, and the main thing that Openstack does is gluing together all of those different components, the hypervisor, the APIs, the web servers that serve those APIs. So it's a lot of glue code, and Python is a great choice for that type of need. Beyond that, Python had a great inclusive community, and being able to tap into a healthy community like the Python community that is worldwide is really great. And also there was a lot of pre-existing libraries that we wanted to take advantage of in the PyPy ecosystem. So that's also a great feature of the Python language that explains why we opted for Python at the start of Openstack. Today, Openstack is 11 years old, and where is it? It's still one of the top 3 most active open source projects in the world. We back in 2015, we had more than 80,000 changes being accepted every year. Now we are more at 35,000, which is the equivalent of the Kubernetes project. So you might hear a lot about Kubernetes being very active those days, but Openstack in 2021 was still in the top 3 projects, the most actively developed projects with the Linux kernel, Chromium, and Kubernetes. It's software that runs in production, and we'll see a few examples a bit later. It's created a community of practice around it. So we have lots of operators of Openstack joining our events and sharing their experiences. And we also built a full software factory around it. We have a system that allows us to process that rate of change activity while maintaining a very high quality, and we'll talk about that a bit later. You can see here the full picture of all the OpenStack components. So it's a full cloud infrastructure framework. We support virtual machines, containers, bare metal machines, networks, functions, object storage, block storage, file systems. So it's a very complete framework for deploying a full public or private cloud infrastructure. Looking at users, we actually were surprised. I mean, I've been involved with OpenStack since the very beginning, and I've been very surprised with how much deployed it ended up being. In our latest user survey from last year, we counted more than 25 million cores of CPU power being driven directly by OpenStack deployments around the world. And you can see a few of the well-known companies that are using OpenStack in this big diagram. Last year, we also had a number of companies declaring deployments that are above 1 million CPU cores just by themselves. So Line, which is a messaging company based in Japan, Walmart Labs, which powers the largest company in the world, Walmart, having all of their stores using OpenStack for their e-commerce platform. China Mobile, which is actually the largest OpenStack deployment right now, is a major mobile phone company in China serving more than 1 billion customers. And their deployment is above 6 million CPU cores. China Unicom is another China-based telecom companies. Workday is a software as a service company based in the US. And Yahoo is the well-known brand. It's also a massive bare metal deployment for OpenStack. So all of those deployments are above 1 million CPU cores being driven by OpenStack. And that's just amazing. Like I said, when we started OpenStack, we never envisioned that it would grow as so big. Okay, so that's what happened in the past 10 years. But I wanted to reflect back on what did OpenStack bring to Python, because this is PyCon Iran, so I figured I should mention that. So if we look at what OpenStack brought to Python, it brought a lot of jobs because there was funding for new Python developers, full-time Python developers working on OpenStack, a lot of them. At one point, we had more than 8,000 people being involved with developing OpenStack over the past 10 years. And so that means a lot of Python developers. It means a lot of cloud and sysadmin and DevOps role as well. It's not just developers. And so that's, I feel like one of the big thing is that it brought Python into a new world, which is the world of providing infrastructure. It added quality. We run more than 20,000 tests every day to process the changes that are proposed for OpenStack. And so with that rate of testing, that exposes bugs in all of Python. We detect issues in newly released Python libraries really, really fast. And I cite a few examples on this slide. You can see that, for example, for PyMemCache, there was a regression on exceptions, and we caught it the day the library was released, and the fix could be shipped in the same day for all of Python users. So it's really a fast turnaround that our testing infrastructure provides. Kazoo 2.1 had a rare deadlock when acquiring a log that is already acquired, but with 20,000 tests per day, the next day, the day after the library was released, we detected the issue and we were able to warn the developers, and they were able to issue a fix and fix it for everyone else. So it's really great that we have this test bed for all of those libraries, and we really try to use the latest version so that all of the Python community can benefit from our running the latest versions of all libraries. NetAddr is another example of a regression that we caught really, really fast with our framework. We also added a lot of contributions. There was a lot of an influx of new developers coming to the Python community. We did contribute to a number of upstream Python projects. We also contributed new Python libraries to PyPy, including Cliff, which is a CLI management tool, Stevedore, which handles plugins, PBR, which is a build system, Debt Collector, which handles deprecations, all of those things that we did not find a good library in the Python ecosystem for. We created it and contributed back to the Python ecosystem. We also created new Python tools. Zool, which I will talk about in a few moments. Bandit, which is a security static analysis parser. Reno, which handles release notes for the software. GGB, which is the Jenkins job builder, which allows you to create Jenkins jobs using YAML and convert them directly into Jenkins jobs. We also adopted libraries because in some cases, libraries that we were relying on ended up being abandoned by their creators. So we had to maintain them for the benefit of the rest of the community. So it's really a significant contribution of OpenStack to the Python community. So I talked about the past, I talked about the lessons for Python. What's the future? What will the next decade of OpenStack and open infrastructure bring? What should we expect? Well, first, we should expect more open source. Open source is pretty ubiquitous today, but we expect more and more usage of open source in infrastructure. We are seeing a lot of concerns around digital sovereignty that really drives more usage of open source for providing infrastructure. So that's definitely a trend we're observing. We'll see more use cases, more diverse use cases, especially on the infrastructure side. We'll see infrastructure for edge computing. It's almost impossible to do edge computing without open source to sustain the scale of deployments that are required. In order for any standard to emerge at the edge, it will have to be very widely shared, and so we expect open source to play a critical role. We see more open source being used in containers infrastructure, combining the power of OpenStack for the raw resources combined with Kubernetes as an application orchestration layer. The two solutions are increasingly used together. We'll see more open source being used for providing infrastructure around artificial intelligence and machine learning workloads, which are becoming more prevalent every day. And lower in the stack, we're seeing more open source being used to provide raw access to the internet via 4G or 5G mobile core network stacks. So the needs for open infrastructure clearly go beyond OpenStack today. OpenStack really cornered the area of the data center infrastructure as a service cloud, but we are seeing more usage of open source in infrastructure in all of those new use cases. And that means new projects, more projects for open infrastructure. And that's actually why we renamed the OpenStack Foundation to the Open Infrastructure Foundation, because today open infrastructure means a lot more than just OpenStack. And as those new use cases become more obvious, open source communities will form to build those missing pieces. So we want to be there to be able to support all of those new communities that will build the next generation of open infrastructure solutions. For example, we already have a number of projects that were created in the Open Infrastructure Foundation. I mentioned Zool earlier. Zool is the Python, written Python. It's a continuous integration system with very advanced features like speculative gating and cross-project dependencies that we use to sustain the scale and the complexity of OpenStack deployment. And now it's a completely separate project. It has a large uptake in the automotive industry, which has also very large and very complex software stacks. So I recommend you to have a look at Zool if you want to do proper tests before you accept the code in your deployments. We have other projects like Kata Containers, which you might have heard of. Kata Containers is a secure container runtime. It's combining the speed of containers with the isolation properties of virtual machines. It's really interesting. We have Airship, which is a deployment tool for declaratively automating open infrastructure provisioning. It's being used by AT&T, and that solves a major challenge for operators, which is the deployment of those complex stacks. And finally, we have Starling X, which is an opinionated distribution of open source technologies, including OpenStack and Kubernetes, but tailored for the edge and industrial use cases. This really helps address the challenges at the edge. And all of those projects really point for a need for more collaboration. It's clear that in the next decade of open infrastructure, there will be more and more open infrastructure technology pieces. And getting all of those technology pieces, all of those building blocks to work well together, that the idea it will require a lot of collaboration around the combination of them, which means we will have to work to facilitate that integration, test that all of those things work well together. But beyond that, we'll need to collaborate without boundaries, between all of our communities, and not limit ourselves to the project that we directly support. This will allow our community of open infrastructure operators, which combine technology pieces from all over, to share their experience and best practices between peers in open events like our Open Infrastructure Summits. So this is really what, in my opinion, the next decade will bring us. And will be open infrastructure everywhere. We'll see more projects, more technology pieces, and we'll need to facilitate that integration. We'll need more sharing, more collaboration without boundaries. That makes the Open Infrastructure Foundation even more relevant for the next decade, even more necessary. So our next step is the Open Infrastructure Summit. It will happen in person in June in Berlin, Germany, and I hope that some of you will be able to join us. If you're interested, you can have a look at openinfra.dev/summit, which is where you can register or learn more about the event. And that's all I had for today. I hope that you learned a few things about OpenStack, about the history of the Open Infrastructure Foundation, what we stand for, how we operate, how we openly collaborate, and what Python, why we selected Python in the first place, what we brought back to Python through the OpenStack experience. And I hope you have a good day of presentations at PyCon Iran. And thank you for your attention. Thank you for listening. And don't hesitate to reach out if you have questions.